Hi to all of you. So today we will discuss about the important topic, that is instruction formats in computer organization. So here we have different types of instruction formats like 3 address instruction format, 2 address instruction format, and 1 address and 0 address instruction format, as well as RISC instruction format. So coming to the first topic, that is 3 address instruction format. So here in 3 address instruction format, so we have to take one example, that is a plus b into c plus d. So here we can evaluate the expression by using 3 address instruction format. So like this. So firstly it will access the values of a and b into the addition of a and b into the R1 register, and then addition of c and d into the R2 register. Then it will perform the multiplication on R1 and R2 register, and the resultant will be stored in M of X. So and go for 2 address instruction. So here the 2 address instruction same expression can be evaluated in a different manner. So here it will access the either 2 variables or 2 registers, or either combination of variable and register also. In 2 address instruction format, firstly the memory of A value will be stored into the R1 register, and the memory of B in the next step. Okay, so it will automatically done the addition operation on R1 with the M of B, and the resultant will be again stored into the R1 register. Then the next step, that is moving of C value into the R2 register, as well as performing the addition operation on R2 register as well as the M of D. So here R1 can holds the value of A plus B, and R2 can holds the value of C plus D. So then finally we will go for multiplication of both the things, that is mul of R1 and R2. So that will leads to the it will leads to the final content. So here we can perform the mul of R1 and R2 register, and then finally we will store the information, that is final resultant, into the M of X. Then go for next, that is 1 address instruction. The same expression can be evaluated by using 1 address instruction also. So here we can use accumulator. We know that accumulator is a temporary register for holding the information for some time. So here in 1 address instruction, it will supposed to access the value of either register or either variable one at a time. So here firstly it will loads the value of A into the accumulator, and then perform the addition on accumulator with the M of B. Then the resultant will be again stored into the M of D. So again go for next, that is C plus D operation, that is loading of C value and addition of D value. So here we can perform the C plus D value, that is accumulator value plus M of D, and then the resultant will be again stored into the accumulator. So then finally so M of T holds the A plus B value, and accumulator will holds the C plus D value, so that we can perform the multiplication operation on M of T into the accumulator, M of T into accumulator, then we can get the resultant. So then finally we have to send the accumulator information, that is resultant value, into the another variable, that is M of X. Then go for the last, it is not only a last, that is 0 address instruction. So here in 0 address instruction, it will use the stack operations, that is pushing and popping, for performing the any arithmetic operation. So initially it will stores the it means pushing A value into the top of the stack, and then pushing the B value into the top of the stack, and then perform the addition operation on A plus B, that is top of the stack. Okay, and then again it will perform the push operation on C and D values. Again it will perform the addition operation on C and D. then it will go for next step, that is multiplication. So that is multiplication in the sense the last two topmost values will be again popped from the stack, and then perform the multiplication on the corresponding values. So when we are observing all these four types of instruction, so zero address can have number of iterations to complete the task, and then the one can have number of operations when compared to the 2, and 2 can have number of operations when compared to the 3. So then finally go for RISC instruction format. So here it is very easy to handle by using RISC instruction, that is, as we know that reduced instruction set computer, that it means. So here it is a different from the all these three instructions. So here we can load all the values at a time and then perform the corresponding operations on the variables. That is, here we will load the A, B, C, D values into the R1, R2, R3, R4 registers, and then perform the addition operation on R1 and R2, and the resultant will be stored in the R1 register, and again perform the addition operation on R3 and R4, and the resultant will be again stored into the R3 register, and then perform the multiplication operation on R1 and R3, and the resultant will be again stored into the R1 register. Then finally the R1 register can transfer the information into the M of X. So this is the different types of instruction formats will be available in the computer organizations. Thank you.